Approximating radicals using decimals. In this video, you will learn how to write a radical as an approximate decimal, both using logic and a more exact method. There are a lot of applications of square roots that you will learn about, and a lot of times it's more useful to say something like, the board needs to be 5.83 feet long instead of the board needs to be the square root of 34 feet long. Although this value is more exact, this is more useful in real life. Let's start with some prior knowledge. If I wanted to plot 2 4/5 on the number line, I would know that it's between the integers 2 and 3, and that it is closer to 3. If I wanted to be more exact, I could divide my number line between 2 and 3 into fifths. 2 and 1/5, 2 and 2/5, 2 and 3/5, 2 and 4/5, and 2 and 5/5 would be the number 3. Therefore, my value is going to fall right there. If I wanted to write this as a decimal, I would need to either know that 4/5 equals 0.8, or divide 4 divided by 5 to get 0.8, so 2 and 4/5 equals 2.8. We could have used logic to approximate that it was closer to 3 than 2, but to get the exact value on our number line or as a decimal, we need to do a little bit more work. We can use the same logic with 4 and 3/7. Logically, if we wanted to approximate the decimal for 4 and 3/7, we can see that it's going to be closer to 4 than it is to 5, and it's a little under half. So you might approximate something like 4.4. If we wanted a more exact value, we would do 3 divided by 7, and we would get 0.42857, and it keeps going from there. So 4 and 3/7 is approximately 4.42857, and the ... shows that it continues. We're going to use the same strategies with square roots. The first thing I need to do is figure out which integers the square root of 11 is between. So I know that 1 is the same thing as the square root of 1, 2 is the square root of 4, 3 is the square root of 9, 4 is the square root of 16. So I know that my square root of 11 is going to be between the square root of 9 and the square root of 16, so it will be between the integers 3 and 4. Since square root of 11 is closer to the square root of 9 than 16, I know that it's going to be somewhere about here. If I wanted to, I could even zoom in on my number line, and I could divide between the square root of 9 and the square root of 16, so I'd see square root of 9, square root of 10, square root of 11, square root of 12, square root of 13, square root of 14, square root of 15, and finally we get to 4 with the square root of 16. Using logic, I could approximate that this decimal is going to be about maybe 3.2 or 3.3, because I know that my value is going to be closer to 3 than it is to 4, and it's not quite at half yet. If I want to be more exact than this, I could actually set up a fraction, and I could say that we are 2/7, because we divided this into 7 segments of the way between 3 and 4. And then I could figure out, well, what is 2/7 as a decimal? And 2/7 as a decimal is about 0.286. Therefore, I could say, okay, well then a better decimal approximation is going to be 3.3, because I know that we're 3 and 2/7 of the way across, approximately. So about 3.3 is the same thing as the square root of 11. I'll do one more example. The square root of 200 is between the square root of 196 and the square root of 225. I chose those square roots because they have perfect square radicands, and they simplify to the integers 14 and 15. Since I'm much closer to this one, the square root of 196, I know that I'll be closer to the number 14. So I would guess that the square root of 200 is approximately 14.2, maybe even 14.1 or 14.3. It's certainly not close to halfway between them. If I wanted to get a more exact decimal, then I'd say, well, I'd write these 3 radicals, the square root of 196, the square root of 200, and the square root of 225. We are 4 away from 196 out of the total distance of 29. So that means that the square root of 200 is approximately 14 and 4/29. You can do long division, and you can get that 4/29 is 0.138. So therefore, the square root of 200 is about 14.138. Now, if you actually type it on a calculator, the square root of 200 is 14.142. That's pretty close. So we use this method where we figure out the fraction that basically creates the decimal for our square root to get more exact. We can get to the nearest hundredths place if we want to. You might be wondering why this method works. If we look at the graph of the square root of x, we can see that it's a curved line, which makes sense because the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. This does not form a linear equation. However, the further out we get and the larger the radicand is, the more linear our line looks, and so the more accurate our decimal approximation is. You notice that the square root of 11, the decimal approximation was the same to the nearest tenth, but not to the nearest hundredth. The square root of 200 was even closer with our decimal approximation, and the larger the radicand is, the even more accurate that fraction, and in turn, that decimal will be. Now it's your turn to try a few. The nice thing is you can always check your answers on a calculator. Use logic first to make a decimal approximation, and then use the new method with the fraction to make sure that your answer is correct to the nearest tenth, or maybe even hundredth.